D flip-flop is an electronic device that is known as delay flip-flop or data flip-flop, which is used to store a single bit of data. D flip-flops are synchronous or asynchronous. Now we can come for the program. Assign a module DFF means data flip-flop, and it consists of D, Q, QB, clock and RST. Here CLK means clock and RST. Input D, clock and RST. Output consists of Q and QB. Here registered Q to QB. QB is registered with QB, and it always consists of A of CLK. CLK means clock. Now begin with if statements. If RSTQ less than or equal to 0, a synchronous reset, or else if it begins with case of D, 0 of Q less than or equal to 0, or it consists of 1 is to Q less than or equals to 1. Now end the case. End. And then assign a value for qb is equals to inverse of q. End module. Advantages of D flip-flops are: D flip-flop is very simple to design. The computation speed of D flip-flop is very fast as compared to other flip-flops. D flip-flops require a very few components to design, which makes it simple to understand. And meanwhile, it also has a D advantages. D advantages of D flip-flop are glitch prone. When input varies fast, flip-flop output may change. It is hard to identify and fix it. And next type of flip-flop is SR flip-flop. SR flip-flop. It is a flip-flop with two inputs. One is S and other is R. S here stands for set and R here stands for reset. Set basically indicates the set of the flip-flop, which means output 1, and reset indicates resetting the flip-flop, which means output 0. Now we can come about the program. SR flip-flop. Assign a module SRFF. Set reset flip-flop. It consists of SRQ, QB, clock and reset. It consists of inputs SR, clock and RST, and consists of input Q and QB registered with Q and QB, and always consists of clock, and it begins with if RST reset of Q less than or equal to 0, or else begin with S, R. 2b of 0. Now assign a values like decimal values 0001 and 10 and 11. 2b of 00, q of less than or equal to q. 2b of 01, q of less than or equal to 0. 2b of 10, q or less than or equal to 1. End case. End. Assign value of qb equals inverse of q. End module. Now we came of the truth table. Here S, R, Q and QS. Here S and R are input and output. Q refers to present state and QS represents the previous state of this output. Truth table of SR flip-flop stands as here. Now JK flip-flop. JK flip-flop is one of the sequential logic circuit which stores binary information in bitwise manner. It consists of two inputs and two outputs. Inputs are set J and reset K, and their corresponding outputs are Q and Q dash. JK flip-flop has two modes of operation, which are synchronous mode and asynchronous mode. Now we came across the program. It consists of module JK. J means set and K means reset flip-flop. It consists of J, K, Q, QB, clock and reset. It consists of inputs J, K, clock and reset, and output of values Q and QB, and registered with Q and QB, and it is always assigned with clock. Begin with if RST reset value of Q less than or equal to 0, or else begin with case of JK. 2B of these are the decimal values. 2b of 00, q less than or equals to q. 2b of 01, q less than or equals to 0, and so on. it is end with end case and end, and then assign qb equals inverse of q and end module. JK flip-flop has a truth table J, K, Q of T and Q of T plus 1. J and K are the set and reset values, and Qt is the assigned value of present assigned value of inputs, and Q of T plus 1 is the next assigned value of uh, uh, assigned input values. And these are the JK flip-flop outputs and SR flip-flop output and D flip-flop output. Thank you.